I did. Thank you very much. I forget a lot. That's why I have it written in all sorts of ways. Okay, what do you remember about exponents? What do you remember about exponents? It starts with x. Is that what you said? I love it. Okay, let's make x our base. X is our base. So give me an example of an exponent that goes along with that x. Squared. We do lots with squared. X squared. What does x squared mean? What does x squared mean? X times x. Good. Now think about those rules of exponents. Rules of exponents. So if I've got x squared times x to the third, what do I do with those two exponents? Add them together. So I get x to the fifth. Good. Now, what if I am dividing those exponents? What if I have x to the fifth divided by x to the fourth? What do I do with those exponents? Good. Okay, and so then I'm left with x to the first, and that's something that I don't necessarily have to write. I don't have to write that 1, but that 1 is always there. So what we're going to focus on a lot today is this principle right here. Okay? It's the division of exponents is what we're going to focus on. So kind of keep that rule in mind, or that property in mind for division of exponents. Now, tell me, what does an A student do? And it is not about being smart. It has nothing to do with being smart. What does an A student do?
Study.
Practice. I also heard study. Thank you. And I would just remind you that studying in math means that you are doing the problems. You're doing the homework. You're doing the practice tests. All of that happens before your test. There's no reason to do any of that after the test. Okay? All that happens before. What else does an A student do? Okay, time yourself. So manage your time as much as anything. What else?
I know it's easy for a lot of people, myself, when doing homework, just like it's easy for you to focus in on just getting it done. It helps to try to focus on actually learning the material.
Good, good. You're not just trying to get it done, you're focusing on learning. What are some very specific habits, very tangible things that an A student does? All of you did it today.
Showed up.
You showed up to class. Okay? Come to class. Okay? What's going on in the library? What's there? Good. It's LEC. That's what it's called, right? Okay. And I know there's a few other tutoring resources through Trio and Great Start. Those are a couple other things that are available. What do I do before every test? What did I say? Talk a lot? Is that what you said?
I said turn off my phone.
Oh, okay. Yeah, you do have to turn off your phones. Review sessions. Okay. And I understand that some of those review sessions may not be feasible for everybody to come. But I will tell you, the people that come, they typically do well. And I can't meet everyone's need with those review sessions. But I'm happy to listen to you if you say, hey, I can't come to the ones you do at this time because I have class. If you moved it slightly later, I could come. I can't promise that I can rearrange it, but I do appreciate the feedback. Now, I like to kind of go over this again. I know we talked about this a lot at the beginning of the semester on the first day of class. I like to go over it again, typically right after your second test. Just for you to kind of do a self-evaluation. What am I doing? Am I doing these things? I know that math is not a lot of your passion. That you don't wake up every morning and say, yes, I get to go to Alicia's class. Okay? But the reality of the situation is you do not graduate from college if you do not pass my class and one more. Okay? And so these are the things that students do that get A's and in turn pass the class. So think about that. So if there's any, it's not too late to adjust habits. It absolutely is not too late to adjust habits. So if you need to adjust any of your habits, do that. Now, I also know that you're taking 3 to 4 other classes. Believe me, I get it. And this class is time consuming. But my response to how much time this class takes is, do you know what will take more time? Taking it again. Okay? Taking it again takes more time than anything that you would have to do in this class right here. And I will help. Now, I think the withdrawal date is coming up. I think it's approximately March 15th. Is it? It is March 15th. Oh, good. Good. I didn't know that for sure. I was going to check. I would encourage you to come and chat with me. If you're thinking about withdrawing, just come and talk. And we can decide together if that's a reasonable thing to do. Okay? And it may be a situation where it is a reasonable thing to do. And that's okay. Okay? But I also want you to have a realistic understanding of where you're going and if you can salvage the semester. So that's what I want if you're thinking about it, please don't hesitate to come and talk to me about it. Okay? And that's it. I'm going to go on from there. So, whoa, that's not what I wanted to see. I forgot I did that later, so here we go. Okay. What we're going to do now is we are going to talk about simplifying rational expressions. Rational expressions are fractions with variables. That's what a rational expression is. Okay? Fractions with variables. So we are going to take all the properties that we've learned about fractions and we're going to apply those to rational expressions. Okay? So we're going to look at 18 divided by 24 and negative 36 divided by 63. And then we're going to take what we do with those and we're going to apply it to everything else that we do. So when I simplify 18 over 24, I ask myself, is there a factor of 18 that's common with a factor of 24? Another way that you might phrase that is what goes into 18 and 24. Okay? So what number goes into both of those? 6. And 6 goes into 18. Okay? 6 goes into 18 3 times. And 6 goes into 24 4 times. So this simplifies very nicely to 3/4. Now, some students look at 18 over 24 and they immediately say, oh, both of those are even. Both of those are even. And when a number is even, what is it divided by? 2. Okay, so you might look at that and say, oh, both of those are even. I'm going to simplify that to 9 over 12. And that is a reasonable thing to do as long as you don't stop there. As long as you say, oh, I can do it again. But this time, what goes into both of them? 3. Okay? So, you are always going to pause at the end, and you're going to ask yourself, have I simplified this completely? Okay? So be sure you take a look at that final answer that you get and see if there's anything else that can be simplified or canceled out. So, negative 36 and 63. What goes into both of those? 9. Okay, so for this, got negative 36 over 63. 9 goes into 36 4 times. 9 goes into 73 7. Is that correct? Good. What's there a danger of you forgetting? Yes. Okay? It's dangerous that you might forget that negative sign. So I do want you to be sure you're careful with that. So for here, we've got our final answer here is negative 4 over 7. Now, I'm going to walk up here to this board right here, and I want us to just look at something. If I've got negative 4/7, you are almost always going to see me put that negative in the numerator. Okay? It's easier to distribute when it's in the numerator. It's easier to not cancel it out incorrectly if you've got something in the denominator. I just always put it in the numerator. And mostly I put it in the numerator in case I have to distribute it across a polynomial. But I want you to know that if I wrote it like this, with my negative in front of the fraction, these two things mean exactly the same thing. And you're fine with that. You will less likely see it look like this. But I want you to know all of these are acceptable. Your negative 4 over 7, your negative 4/7, and 4 over negative 7. They're all the same. We briefly talked about that when we talked about slope. We'll talk about it again when we talk about slope right at the end of the semester. What I want you to realize, it does not mean that. Okay? This is negative 4 over negative 7. This is wrong right here. It doesn't mean that. It means any of these, but it does not mean negative over a negative. So just kind of keep that in mind as you work with those. So now we are going to throw in variables. So I have 15xy in my numerator and 25y in my denominator. Okay, 15xy over 25y. What I encourage you to do is always focus on the numbers first. Focus on those numbers first. What goes into 15 and 25? 5. So my 15, 5 goes into 15 3 times. 25, 5 goes into 25 5 times. Okay? Now, I don't have an x in the bottom. I only have an x in the top. So I leave my x. I've got a y in the numerator and a y in the denominator, so that can also cancel. So I have 3x over 5. Because of us crossing and canceling and everything, sometimes students lose variables. So you got to be careful. Some students choose to do lots of color coding. Sometimes they mark the variables out in a different color. Sometimes they highlight what's left. Any of those scenarios, whatever works for you is completely fine. But just know sometimes students accidentally lose a negative sign. Sometimes they drop a variable or an exponent because it kind of gets messed up in what they're doing. So be aware of that. Okay? Yes, sir? You keep the x because there's no x in the denominator. So right here, I can cancel out these two y's right here because I've got a y in the numerator and a y in the denominator. I can't do that with the x because I don't have an x down here. Good question. Good question. Now, I want to briefly also talk about variables. Students, because of this with the negative sign, students want it to also be true with that variable. And it's not. And this really comes into play when we're talking about slope. But this is an excellent time to talk about it as well. Here I've got 3x over 5. Okay? You could also write that as 3/5 x. Okay? So it is okay to have it in front of it, or right beside the fraction, and it's okay to have it in my numerator. Okay? These two things mean the same thing. What I want you to understand, it's very much okay to have a variable in the denominator. Okay? We're going to have lots of variables in the denominator. denominator today. But I want you to understand that this or this means something different. And a lot of you end up writing your fractions like this right here, when what you need to be doing is this right here. And I'm going to prove to you that it's different. Let's pretend in all these scenarios that x is equal to 2. So I'm going to plug 2 in for x. So in this scenario right here, I have 3 times 2 over 5. 3 times 2 is 6 over 5. Okay? In this scenario right here, I have 3/5 times 2, and that 2 is over what? 1. Okay? Multiply my numerator, multiply my denominator, and I get 6/5. So you can write it here, and you can write it here. These are interchangeable. This is not. It's okay to have a variable in the denominator, but it does not mean what these two mean. So I've got 3 over 5 times 2. So my 2 is in the denominator. When it's written like either one of these, you're telling me that the 2 is in the denominator. That equals 3/10. That is different than 6 over 5. Okay? So I'm just wanting you to be aware. These two are equal. They're the same. This is not. It's different. And again, it's okay to have a variable in the denominator. I just want you to recognize that it means something different than having the variable right beside the fraction. Okay? And the time that comes up the most is slope. That's when that comes up the most. Okay, so let's do the next one. I've got negative 28a squared b squared over negative 63a squared b to the third. Okay, and I'm going to rewrite this because I got a little too optimistic with how many problems I could put on one screen. Okay, now, what I would encourage you to do is take it numbers first, then we're going to deal with our A's, and then we're going to deal with our B's. Thank you very much. Appreciate that. Okay, here we go. So negative 28 and negative 63. Let's deal with the negative first. What's a negative divided by a negative? Positive. Okay, so my answer is going to be positive. So you could go ahead. Negative divided by negative is a positive. Okay? 28 and 63. What goes into both of those? 7. Good. So I'm going to mark out my 28. I'm going to put 28 divided by 7 is 4. Okay? My 63 divided by 7 is good. Okay. So I have dealt with my numbers, my coefficients. Okay, now I want to deal with my a squared and my a squared. Okay? I have a squared in my numerator and I have a squared in my denominator. What's going to happen there? They cancel. Okay? So I'm going to mark both of those out. Now, look at that b squared b to the third. We just talked about our exponent rules means we subtract. We subtract. Okay? When I say 2 minus 3, what do I get? Negative 1. So, what happens with that is I'm left with b to the negative 1 in the numerator. And based on our exponent properties, when I've got a negative exponent, where does that go? If I've got b to the negative 1 in the numerator, so if I've got b to the negative 1 in the numerator, what does that mean? It's the reciprocal. Okay? So when you've got a negative exponent that to the denominator with the exponent, it's just not negative. So b to the negative 1 means 1 over b to the first. Now, what I encourage students to do, if I've got b squared over b to the third, think about what that means. When you're not sure how to apply that property, think about what that means. It means b times b in the numerator, and it means b times b times b in the denominator. So I am going to simplify a b on the top and a b on the bottom, another b on the top and another b on the bottom. So I've got 1 left over, and where is it? The denominator. Okay, so this simplifies my b squared, simplifies out, and I'm left with 1. B squared divided by b squared is 1. And my b to the third just becomes 1. So again, I've got my 4 here. I don't have anything else in the numerator. I have a 9 here and a b here. So my answer is 4 over 9b. Okay. Okay. Yes, sir.
Would it be wrong to put the b on top of 4?
That is a great question. So you're asking me, this right here, is it the same as this? Okay? Do you remember when we plugged 2 in, we got 3 over 10. When I plugged 2 in up here, I got 6 over 5. So if it's supposed to be in the denominator, which is bottom, and I put it in the numerator, it's not the same thing. So it's very important that wherever that variable goes, that we keep it there. Okay, that's a great question. Thank you. Okay? Okay, now, 18.
What if I have b and negative 2? Like, would I still do it the same way? Like 2 or
Okay, ask that question one more time.
what if I have b and negative 2? Like, b squared, but is a negative 2.
Okay, so is it negative 2 times b, or is it b to the negative 2 power?
b to the negative 2.
Good. That has to be in the denominator. It would be b squared. Okay, so it's kind of, it's going back to this negative exponent right here. B to the negative 1 is 1 over b. So b to the negative 2, that's going to be 1 over b squared. Okay, so this means it's a reciprocal. You're moving it to the denominator. Good question. Okay, now, I want you to look at 18 individually, 24 individually, 15xy, 25y. I'm dividing. What type of polynomials am I dividing? What type? I've got one single term. So what's the single terms called? Monomial. Okay? So what I'm dividing here are monomials. I have a monomial divided by monomial. That's what I'm doing. I'm simplifying that out. I'm going to move into binomials and trinomials. So we're going to start simplifying binomials and trinomials. So I want you to look at what the rules were here. Negative 63 was multiplied times a squared, which was multiplied times b to the third. I can simplify out factors, things that are being multiplied together. What I want you to realize is that when I move to binomials, okay, I can't just simplify out the x. I've got to look at those things as units. I've got to look at them as units. So at this point, what we do is we factor. You have to factor first. You have to factor first. Before you start simplifying anything, you want to make sure you have factored these completely. Now, here, I have a binomial divided by a binomial, and then I have a trinomial over a trinomial. So in my numerator, I have an addition sign. That's my clue that I need to factor. So look back at the numbers that I was just looking at. Okay, in my numerator, The only thing going on in my numerator was multiplication. The only thing going on in my denominator was multiplication. So then I just started simplifying whatever I could simplify. As soon as we add and subtract within the denominator and within the numerator, we have to factor. That's your key. You can't just cancel those x squared because they're both x squared. Because it is x squared plus 4x. So before we do anything, we factor. Okay, I told you factoring wasn't going away, didn't I? So we are going to factor. So we're factoring completely. So I'm going to do the first one. I've got x squared plus 4x. I can simplify or pull out, factor. I should have said factor. I shouldn't have said simplify. I can factor out an x. And then I'm left with x plus 4. Okay? Now I have x squared minus 16. How does that factor? It's difference of perfect squares. Okay? So what does that factor to?
X minus 4, x plus 4.
Got it. X plus 4, x minus 4. Okay? Now, my binomials that I have factored to are a unit. I can't separate the x's and the 4's. Okay? So I can simplify x plus 4 and x plus 4 because they are the same exact binomial. Okay? So I am going to cancel that out. So I have x plus 4 and x plus 4. Then I am left with x over x minus 4. X minus 4 is a unit. It is together. It is a binomial factor. You cannot separate the x and the negative 4. So I can't simplify the x on the top and the x of the x minus 4. Those are two different factors. The x and the x minus 4 are two different things. You have to keep x minus 4 as it's one unit. It's together. Okay? Now what I want you to do, I'm going to give you about 60 seconds to do it. I want you to factor 6a squared minus 7a plus 2. I want you to factor that, and I want you to factor the denominator.
In typical Adam McCain fashion, I've seemed to have misplaced all of my stuff yesterday.
Okay.
Do you mind if I work this on my phone?
That's fine. Okay. 6a squared minus 7a plus 2. You're factoring that, and you're factoring 10a minus 15a squared. Oops, I didn't set the timer. Okay, I'm going to go ahead and factor down here. And we've spent a whole chapter on factoring. 6 times 2 is my product. Okay, so I've got a product of 12. What's my sum? -7. So I'm looking for two numbers multiplied together, give me 12. Added together, give me -7. What are those two numbers? -3 and -4. So I split my -7a. So I say 6a squared minus 4a minus 3a plus 2. Factor by grouping. 2a comes out of the first two. I'm left with 3a minus 2. What comes out of the next two? -1. Excellent. -1. There's your key right there. When that term right there is negative, you're going to be factoring out a negative. So -1 times 3a minus 2. So I have 2a minus 1 and 3a minus 2. Okay, so I factored my numerator. So 2a minus 1, 3a minus 2. What did you take out of the denominator? What did you take out of both of those? 5 and? Good. So I take 5a out of both. I'm left with 2 minus 3a. Now, at first glance, it appears that nothing can be simplified. I can't cancel anything out. There's nothing in the numerator that's like what's in the denominator. Do you see anything that's similar? They're not exact, but they're similar. Tell me what you see.
3a minus 2, 2 minus 3a.
Good. 3a minus 2 and 2 minus 3a. So one of the things is you want to look for that because we can simplify this further. These are not exact, but they are similar. So we've got to figure out what can I do with those two to be able to simplify them because they've got to be the same. Okay? So what I'm telling you, so what I want you to start recognizing is that 3a minus 2 divided by 2 minus 3a, that gives us negative 1. Okay? That gives us negative 1. So, I want us to go back to 10a minus 5a squared. I want to go back to 10a minus 5a squared. Standard form, you traditionally have the highest exponent first. Okay? It doesn't matter if it's x squared, x to the third, x to the fifth. When you write something in standard form, your highest exponent comes first. And we've talked a little bit about that when we were adding monomials, adding polynomials. It's not incorrect to put x squared before the x to the third. Traditionally, the x to the third comes first. So this is written in a way that's different than what we would consider in standard form. If I were to rewrite this as negative 15a squared plus 10a, have I changed the value of that in any way? Have I changed the value of that in any way?
No.
No. I've got several people shaking their heads. No, I have not. My negative is still in front of my 15a squared, and my positive is still in front of my 10a. So I haven't changed the value of that at all. But because I've rewritten it in standard form with my a squared first, I might be more likely to take a negative 5 out of both of these instead of just a 5. And when I take a negative 5 out of this, and I'm actually, don't forget your A needs to come out too. So when I take a negative 5a out of this, then I'm left with 3a minus 2. And that allows me to simplify. So I want you to be on the lookout for that when you are simplifying, because now I can do that. And so my final answer then is 2a minus 1 over negative 5a. And you can write that negative in all sorts of different places, just like we had up there where we've got the negative in the numerator, we've got the negative in front of it, we've got the negative in the denominator. Okay? So be on the lookout for that. Rewriting 10a minus 15a squared as negative 15a squared plus 10a might make a difference in triggering your brain on what to factor out. Okay? Okay, you ready to take it up a notch? Yes, Alicia, we would love to. Okay. So what we've been doing is simplifying. Now we're going to move into multiplication and division. And we're probably only going to get to do a couple problems with multiplication. Think about how we multiply fractions. And what happens is students look at fractions, they get a little anxiety about fractions, and the only thing they ever remember about fractions is least common denominator. And so time and time again, I've got students that are multiplying and dividing fractions, which in turn are the rational expressions that we're dealing with now. And they try to find a common denominator when they're multiplying and dividing. You don't need a common denominator when you're multiplying and dividing. So what we're focusing on today is multiplying and dividing. You don't need a common denominator. Okay? So I'm going to write that. Do not need common denominator when multiplying and dividing. Okay? So, one of the tools that we do use when multiplying and dividing fractions is we use cross-canceling. And cross-canceling is when we look at the x. So I've got 2/4 times 4/5. So I am going to look at my 2 and my 5. Is there anything that can be simplified out of 2 and 5? No. Okay. Is there anything that can be simplified out of the 4 and the 4? Yes. 4 goes into 4 one time. 4 goes into 4 one time. So my answer here is 2/5. Now, if I wanted to, I could have said 2 times 4 is 8. 4 times 5 is 20. And then I could have simplified it from there. You will be much happier if you use the cross-cancel method. You will be much happier if you use the cross-cancel method because you are dealing with smaller numbers. And anytime that we're dealing with smaller numbers, it helps us out. Okay, so you definitely want to utilize the cross-cancel. So we're going to do the cross-cancel again for 3x over 4y times 8y squared over 9x. I want you to look at your numbers first. So I'm going to go with my 3x and my 9x. Focus on your number. What goes into 3 and what goes into 9? 3. 3 goes into 3 how many times? Once. 3 goes into 9 how many times?
3.
Good. Okay. Now focus on your x. What can happen with x and x? They cross them out. They cancel. X divided by x is?
0.
Nope, it's not 0. That's a very common mistake. Good. I'm glad you said it then. When we cancel these out, students very often will say 0. It's not 0, it's 1. X divided by x is 1. So when you find yourself with nothing left in the numerator, what's left? 1. 1 is left. 3 divided by 3 is 1. X divided by x is 1. So be careful on that. Very, very common that I see 0 in the numerator when I should have a 1 in the numerator. Okay, now I'm cross-canceling the other direction. Deal with my 4 and my 8 first. What goes into both?
4.
4. 4 goes into 4 one time. 4 goes into 8 how many times? 2. Okay, now, here I've got a y. This is y to the first power. In my numerator over here, I've got y to the second power. This y disappears. It doesn't disappear. We're dividing it. It's gone. My y squared becomes what?
Just be wild.
It would just be y. It becomes y to the first. Okay, now, students lose things here. That's why different colors and highlighters are good. I have a 1, I have a 2, and I have a y. Okay? Here I have a 1 and I have a 3. So my final answer here is 2y over 3. Okay? Okay. We've still got time. Can I move from this screen? Okay. Now, we're back to binomials. We're back to binomials. Anytime you see a binomial or a trinomial as part of a rational expression, what does that clue you in that you need to do? Factor. That's what I need to do. I need to factor. Okay? So anytime you see a binomial or trinomial or polynomial, you are going to factor first. Factor first. Okay? So my y stays the same. So I'm going to leave it as y. X squared minus 4 is difference of perfect squares. So I'm going to say x plus 2, x minus 2. I am multiplying that times x plus 2 over y squared. Now, y squared does mean y times y, and you can write it as y times y if you want to. Typically, I wouldn't. I would leave it as y squared. But now, I'm going to look at cross-canceling. So even when I turn binomials and trinomials into factored form, I'm still going to use that cross-canceling technique. So I've got a y in the numerator and a y squared in the denominator. My y simplifies out, and I'm left with what? In a y where?
In the bottom.
I am left with a y in the bottom. So I am left with a y there. What do I have in the numerator? 1. So I'm left with a 1 right here. Now, do you see how I have an x plus 2 in the numerator and an x plus 2 in the denominator? Simplify that out. What am I left with on that right-hand numerator? I canceled the x plus 2 out, so what am I left with? 1. Okay, so then I've got a 1 here and a 1 here. 1 times 1 is 1. Then I have x minus 2 here, and I have y here. So my final answer is 1 over y times x minus 2. Okay? We have time for one more.
Well, you mentioned that free PDF of the textbook I found that I...
Yeah, let's talk about that later.
Okay.
Okay. Okay. Now, I've got x squared minus x over x plus 5. Then I have x squared plus 5x plus 4 over x to the 4th minus x squared. There is a lot of factoring going on. So I'm going to give you 1 minute to get as much of the factoring done as you can. Okay? You know how to factor these. Okay, minutes up. I'm hopeful that you got quite a few of those factored. X squared minus x factors to x times x minus 1. X plus 5 is already factored. It's down as far as it can go. It's broken down as much as it can. X squared plus 5x plus 4 factors to x plus 4 times x plus 1. X to the 4th minus x squared. You know, the x to the 4th is a little intimidating. But if you see over here, it factors to x squared times x squared minus 1, and then x squared minus 1 is a difference of perfect squares. So now, if it's in the numerator and in the denominator, we can simplify it out. So I've got x minus 1 and x minus 1. X plus 1 and x plus 1. Now, do you see the x and the x squared? That's something you might miss. X and x squared can be simplified. X squared and x plus 4 can't, but the standalone x and the standalone x squared can. So this becomes 1. My x squared becomes what? X. Okay? So my final answer here is x plus 4 over x times x plus 5. And that hidden x right there might be something you would miss. So be careful with that. Yes, sir?
So you can cross out the x plus 1, x plus 1 that they're on top of each other?
Yes, you can. Yes, you can. Yeah, as long as one's in the numerator and one's in the denominator. Okay, I'll see you guys on Friday.